Hi guys, in this video we're going to have a look at box plots. So this is closely related to cumulative frequency graphs. So if you haven't had a look at the cumulative frequency graphs video that I've created, definitely have a look at that because that does talk about the lower and upper quartile. Box plots is just a way of displaying this data, and I'll go into a bit more detail of that in a minute. And it also makes it a little bit easier to compare two different types of data, or even more than two. So let's get cracking. So this diagram here is a box plot, okay, and each one of these lines represents a particular bit of information. The two end bits here, this line here and this line here, the two end bits are the lowest and the highest value. Okay, so as you can see here, the lowest value is 1, so I can put that here. Lowest value is 1 and the highest value here is 10. So the largest value is 10. Okay. The next two, this one here and this one here, the lower one is called the lower quartile and the higher one here is called the upper quartile. So lower quartile in this case is 3 and the upper quartile in this case is called 6. And the one in the middle is the median. So you might recognise the word median from averages, and that's exactly what it is. It is the average of the set of data, or the median of the set of data, and in this case it's 5. Okay. Now, once you've got those bits of information, you can work out the range. So just again, from our averages, we know the range is the biggest value, take away the smallest value. So big, take away small. So that would be 10 minus 1 is 9. So you can also work out the range. And the last one we can do is the interquartile range, or IQR for short. So to say that again, that's the interquartile range, which is the upper quartile, take away the lower quartile. And we say that's the interquartile range. So what does all that mean? Well, the largest and the lowest value is pretty obvious. In the set of data that you have, it is the largest and the lowest value. The median, again, put them all in order, is the middle value. But you might not know is the lower quartile and upper quartile. The lower quartile is the quarter, or 25% point in the set of data, and the upper quartile is 3/4, or 75% of the data. So the interquartile range actually represents 50% of all the data that you're given. And then from the lower quartile to the lowest value, this represents 25%. And from the upper quartile to the highest point, that represents 25%. So essentially you've got the two 25%, and the interquartile range represents 50% of the data. Okay, and as I say, if you've watched the cumulative frequency video, you'll see me do it using that as well. So what does a typical question look like? Well, it could look like something like this. So class or students do a quiz. There are 10 marks in total. We're told the largest value is 9, the upper quartile is 7, the median is 5, the range is 8, and the interquartile range is 4. So we're told some bits of information, and the question wants us to draw a box plot. So I'm going to use the same scale here, probably 1 to 10, because yep, that looks fine. So obviously you can extend it if you need to, but I think that should work. So I shall just draw my scale like so. So 0, 1, 2, 4, 5, 6, 7, 8, 9 and 10. Now sometimes in the exam they might give you a little grid to use. If not, obviously you can just quickly do one like I've just done there. So let's start putting our values down. The largest value is 9. Like I said, the largest value is that far line there. So I will put a line on 9. So that's my largest value done. The upper quartile is 7, so that's that top line there. So in this case it's 7. So I can put my next line on the upper quartile. So that's done. The median, which was that middle line I talked about here, is 5 in this case. So I can put that there. And we're told the range is 8 and the interquartile range is 4. So I'm not told what the lowest value is, or the lower quartile. I'm just told what the range and the interquartile range are. So I have to work out the lower quartile and the lowest value. So if I'm told the range is 8 and I know the highest value here is 9, Okay, I can therefore work out the difference must be 8, so I can go down 8, in which case the lowest value must be 1. Okay, so the highest value is 9, take away 1 will leave me with 8. Just check that the range is 8. Yes, it is. Difference between 9 and 1 is 8. Okay, so I can put my lowest value at 1 there. Exactly the same technique with the interquartile range. I know that the highest value, the upper quartile is 7. I'm told that here. If the interquartile range is 4, I need to go down 4, and therefore the lower quartile must be on 3, like so. Okay, just check it. 7 minus 4 is 3. Yep, the interquartile range works. And then all we do is join up the lower and upper quartile with the median in the middle, like so, hence the box. And then just draw a line from the middle of the box to each of the highest and the lowest points, okay? And that is a box plot, sometimes also known as a whisker diagram as well, okay? Because these are meant to be like little whiskers. So that's a typical type question that you might have to do. What you also might have to do is compare two box plots. So in this question here, okay, we have the test results from Class A and Class B. So here's Class A, here's Class B, and I've just put the scale at the top there. Doesn't matter where the scale goes, usually it's at the bottom, but I just did it at the top here just to show it doesn't matter. Okay, and what the question in the exam will say is compare the data. So there's two main things that you need to talk about here. The first one is the median. Okay, and remember the median is the line in the box plot here. So let's just get the scale. So I think this goes up in 5s, 5, 10, 15, 20, 25. Yes, it does. So if that's 50, this must be 60. So the median for Class A is 60%. And that one is easy, that's 75%. So this would be the first thing that you compare. You'd compare the medians. So the first point that you'd make is you'd say the median of Class A is 60%, and Class B is 75%. So the median of Class A is 60% and Class B is 75%. So that's the fact. You've got the data from there. So I'll make a comment about it. Therefore, the average, because remember the median is an average, therefore the average of Class B is higher. Okay, so I've worked out what the medians are and then made a comment about them. In other words, Class B has a higher average. 75% is obviously higher than 60. So that would get you 1 mark. The second thing to compare is what we call the measure of spread, which basically is looking at the range or the interquartile range. Now, it's better to look at the interquartile range, which remember is the box, than it is the whole range. The reason for that is that with any set of data you might have what's called anomalies or outliers. This just means like very odd, strange data. Okay, it doesn't quite fit the pattern that you may have seen in throughout the whole test or whatever the data comes from. So for example, if I was to use a class and look at the height, theoretically the teacher would be the tallest person and therefore would be an outlier for the height of everyone else. So if it was like a primary school teacher, for example, the average height might be, all the students would be roughly about 1 metre, but the teacher might be 1.6 metres or something. So that would be a random result. But the interquartile range, if you use this, doesn't account for outliers, because remember that's 25% and that's 25%. It only concentrates on the middle 50%. So that's a much better way or measure of spread to look at is the interquartile range. So that's going to be the second thing that I look at. So if I look at the interquartile ranges of these two, for Class A, I have 20% because that's 55, 60, so that's 65 for the upper quartile and 45 for the lower quartile. So 65% minus 45% is 20%. And then let's have a look at this one. So that's 75, so the upper quartile there is 85%, and that's 55%. So the interquartile range, 85% minus 55% is of course 30%. Okay, so the second thing that we'd say is Class A has a smaller interquartile range, okay, because that's 20% and that's 30%. So I'm going to put it, Class B has a smaller interquartile range of 20%, and we say therefore the data is more consistent. Okay, because it's small, it means that 50% of all the data values are really tight together in this sort of area here between 45% and 65%. So we say it's got a more consistent interquartile range. Okay, whereas this one here for Class B is bigger, so it's bigger spread, they're less consistent. Okay, so they're the two things that you would comment on. One would be the median and the other would be the interquartile range. So hopefully that helps, guys, and explains box plots. Thanks for watching.